let's get started. Chris, I know you're in the woods and we don't want your Starlink battery to die. So just in the interest of time, hi everyone, and welcome to your favorite type of webinar, a payload webinar. I'm your host, Mo Islam, CEO of Arkaea Media Group, the parent brand behind Payload. We are the leading trade publication in the space industry with a newsletter that goes out 5 days a week. And by the way, we are a free publication. We don't believe in charging for news, unlike some of our competitors. So if you're not already signed up, visit us, www.payloadspace.com. Very excited to be hosting today's conversation titled Beyond the Build, Unifying Hardware Genealogy Across Aerospace and Defense Organizations. This webinar is powered by our friends at Sift, the observability and traceability platform for mission-critical hardware, which we'll learn a little bit more about today. Today, we are going deep on a topic that's often overlooked, but increasingly mission-critical. Hardware traceability, specifically how leading teams are building unified real-time lineage across test, maintenance, and assembly workflows, not just to pass audits or meet compliance, but to accelerate failure investigations, strengthen quality, and build faster and with confidence. We operate in an industry where reliability is effectively non-negotiable. Too many programs are still flying blind, fragmented data, lost test records, and tribal knowledge that's scattered across systems. So we've brought together an exceptional group who are shaping the future of kind of traceability from multiple angles. So to introduce everyone, we have Karthik Gollapudi, co-founder and CEO of Sift, Yaron, Alfi, co-founder and CEO of Magenta, James Montgomery, Chief Product Officer at Manufacturo, and Product Systems Consultant, Chris Charhut. So guys, before we get started, why don't we just go around the horn, quick 1-minute introductions from all of you in terms of what you do and what your firm is known for. So Karthik, let's start with you.
Awesome. Yeah. Hi, everyone. I'm Karthik. I'm the CEO here at Sift, and we're building what you would call observability and data infrastructure for hardware sensor data. So a lot of what we're building was inspired by what we saw over at SpaceX, where I spent 5 years as one of the flight software leads on the Dragon program. And then now what we want to do is bring a lot of the best practices that we saw towards building complex machines and hardware to the broader industry.
And Yaron, why don't we go to you next?
Yeah, Yaron Alfi, CEO of Magenta. Magenta's focused on introducing specialized AI agents to the manufacturing world. So streamlining tedious workflows that engineers have had to kind of deal with, and basically just helping accelerate and increase bandwidth. And then also been spending a bit of time with the Sift team, working as an advisor to help kind of shape some of the manufacturing focused improvements to the platform.
James?
Yeah, James Montgomery. Good to meet everyone. Chief Product Officer at Manufacturo. I work with a team on building out our manufacturing platform, which is really aimed at fast-moving customers that are engineering forward, right, with high change parts. Prior to this, I was with everybody on this panel at SpaceX, where we were building our homegrown ERP called Warp Drive. And this was honestly one of the major drivers of and vision for Manufacturo and our product and doing that. And prior to that, I was a senior product manager at Sol Systems, formerly Aprizo, building out their MES offering. So been doing this for 25 years, way too long. But yeah, good to meet everyone.
And last but not least, Chris.
So my name's Chris. I spent 8 years at SpaceX, 3 of which I was working on the rocket side under kind of process design for manufacturing and quality systems. And then I moved over to Starlink, where I spent 5 years really building from the ground up our factory digital infrastructure. So our MES and the tools and systems that we use to kind of build this aerospace grade product, but at a super high rate.
Amazing. It's always great to feel like the dumbest guy in the room. So Karthik, I will start with you. Let's start with a very simple but important question. How do you define traceability, and what does genealogy actually mean in a hardware context?
Yeah, of course. So I think there's the broader definition of of hardware traceability, which was, I think, more in the traditional manufacturing sense around how is it that you can track history, location, usage, status of different components. And then there's which actually I think James and the team here can actually give a much more extensive answer to. But I think the part that I want to add on to that is like, where is it that the data infrastructure comes in, and how is it that you can enrich that traceability to be a lot enhanced with a lot of the like hardware sensor data that's gathered throughout the manufacturing process and throughout the hardware lifecycle. So, for example, a lot of these machines nowadays, it's not just about building it and then shipping like a piece of hardware, but it's also about how do you, as that thing operates, it's going to be gathering sensor data, and that sensor data may come from the hardware itself, may come from the test stands that are used to manufacture it. It may come from the tools that you're using to actually go build that piece of hardware. And a lot of what we're doing at Sift is how is it you can enrich that intelligence layer on top of the traditional hardware traceability data that you're gathering.
James, Chris, anything to add from you guys?
No, 100%. Like genealogy is really that subset of like that hardware traceability, and like people think it's this binary switch that you turn on traceability or don't, but it really is a never-ending climb and process. So it's continuous improvement, like to capture like who did what, when, and really what Sift is doing is any of those factors that can affect the outcome and reliability of the part themselves. Like you really need that, and you've got to start that journey, and that's where we see the partnership really strong between our two companies.
Yeah, and I think there's kind of two like core concepts to traceability. There's what I call like the skeleton, which is like the parent-child relationships, right? What got installed into what, right? Part A went into part B went into what's part C, but that on its own isn't. It's extremely important, and it's the core fundamental, but on its own, it doesn't provide a lot of value. And then what you have like on top of that skeleton is like everything else, right? And that's how did this thing test? Did this thing have a defect? What vendor did this come from? Did the vendor have an issue, right? And so it's like, you can't just do the former. You can't just record where everything went if you don't also have the ability to like search through your genealogy tree and find all the specific data that you had when you were building that part. So it's kind of two aspects to it.
And one other thing on that, it's when people think traceability, they think, oh, I have to like record all this stuff, and there's all this extra work and extra bureaucracy there. I think a key is making all of that easy, so it just kind of happens, and it's not like any crazy additional work that people need to do. It's having the systems work with you and kind of support that, so then you're capturing it, as you're doing your normal activities. So I think that's a big thread here as well.
Why is traceability getting renewed attention within kind of aerospace and defense right now? Yaron, maybe let's start with you.
Yeah. I mean, we kind of see all the things that have been happening in the news, like, it's with planes and like installation failures and stuff like that. All of those, people need to determine the root cause, correct them, so then, we could kind of move on and have like safer, reliable machines. So a lot of that stuff, we see it kind of before our eyes. So that's part of it. And I think the other part is just the bar for what an exceptional product is just continuing to rise. Like as more and more companies are coming in, being introduced to the manufacturing world, the bar is just increasing. And so, what used to be like, a choice people had as a manufacturer is now kind of a requirement.
I think additionally, there's a like, we've been building aerospace products for decades, right? But there's been a technology jump that I think's happened in the last 10-ish years that's, I think, enabled, like Yaron said, to make the capture of this kind of information a lot easier. I mean, if you were doing quote unquote traceability, 40 years ago, it was paper and pen, right? And you were writing everything down. And there were probably people whose full-time jobs were to just sit there and absorb that information on paper and pen and translate to a different sort of paper and pen. And then when you wanted to know what was built into what, you talk to a human being and they'd go back to that paper and they'd look, right? And now we live in a world where all that's kind of done in the digital realm. And I think that makes it so much easier for people to adopt, which kind of enables them to want to start doing this kind of thing, because ideally it's as seamless as possible.
Yeah. On that thread, I mean, when I had started at Parker Aerospace many years ago, a lot of the information and test data that we were capturing was pen and paper. So it's like if there was like an investigation we needed to do on a part, that was literally digging through like boxes and boxes of papers to find the test records. You know, to that point that Chris brought up, it's that's exactly spot on. Like with the systems being better, it's becoming a lot easier. So,
But I think also, right, I think we're seeing like the transition from like traditional aerospace and defense into this new commercial space is also where there's the prerequisite of that to scaling is change, right? And the appetite for change is change or die, right? You have to change. So to do that, you need to be able to measure, you need to be able to trust, and you need to be able to know that the pedigree of the part that you're doing, you're not creating risks. And the risks are so much higher now because of that speed. I think because of that, the prerequisite of that is that backbone that Chris was talking about. You need that. And I think it's the demand is coming from the culture rather than the needs or the systems out there, really. I feel like we're being pulled into this rather than pushed.
Karthik, did you want to add something there?
Uh, no, I was actually just going to give a couple interesting examples, which were like, for example, if you think about like the 737 MAX, like that plane's been around or 737's been flying for like 60 years, but it really only started falling out of the sky in the last like 5 years. And it's like what actually changed, which is this like increased complexity. With the 737 example, it was more around this increased complexity from the autopilot software, but we're seeing this increased complexity across with all sorts of hardware, which is causing a lot more challenges when you go build them. So I think when like Yaron and James are talking about, it's like we kind of have to change. It's because we're building more like increasingly complex machines that that are forcing you to actually like some of these things that maybe were, I don't know if it was like a core or maybe more of like a secondary or afterthought type of a focus. It starts to become more of a primary focus if you really want to continue building these increasingly complex machines.
So, we've had product lifecycle management systems, manufacturing execution systems for years. Why do you feel like this has been a really challenging problem to solve to date?
yeah, I could start off there. I think generally those systems have been too disconnected from each other. I think that's probably one of the biggest things. And yeah, let me just start off with that. I'll let others hop in there.
I think also, and James touched on this, which is a really good point, is like there's a transition from traditional aerospace manufacturing moving from being this thing that was previously done by government or like multi-billion-dollar companies to now becoming something that a startup can do, right, with just a small amount of seed money. And however, like you're still building aerospace hardware, which means it's still challenging and things are still going to go wrong, right? And so that requirement to have strong traceability doesn't disappear just because you're a startup versus a multi-billion-dollar company. But now you don't have the level of resource that this large company does in order to actually solve these problems, again, with just by throwing an army of people at it. This guy checks work, and then he checks his other work, and then the third guy checks the third guy's work, and then they all stamp a piece of paper and it goes in the trash, right? So it's like, okay, this software's been around for a long time, but the software's been focused on the customer being this huge conglomerate, right? And now the customer is this, 15-person startup who knows how to get the problem done, but needs access to tools that work the same way they do, rather than kind of how they used to work.
What makes
oh, sorry.
No,
sorry.
go ahead, James. Go ahead.
I was just going to say, I think it has been solved, but it hasn't been solved efficiently. People have done it, but it requires these massive configurations and army of people to do it, or they feel like the solution is filling out like, it feels like if you're filling out a mortgage application every time you're doing something. It's just not efficient. And it's often it's one of the takeaways I've seen. Like we visit hundreds of customers, and I'd be interested to know if you guys see the same thing. Is like everyone feels like they're behind. Nobody feels like they're cutting edge of traceability, and everyone feels like there's a huge wall in front of them that they have to get to. But really, you just got to start, right? And like you've got to make sure you have a platform that allows you to make those changes and make those process changes relatively not as disruptive or requiring a complete system change, like ripping a system out. You've got to have a system that grows with you. But really, it's a two-way street, right? There's the cultural aspect as well. Is I feel like people were, it used to be the three-letter acronym WAR, right? The PLM people didn't speak to the ER people, didn't speak to the MES. And I feel like that this is changing. Like we're seeing like the acronyms are going away. People don't want these barriers. And we're also seeing that the level and appetite for utilizing these tools and consolidating, but also be getting value out of them is and people wearing multiple hats is changing as well. And it's just really good to see. Actually, it's really nice. I don't know if anyone has any comments on that.
No, I agree. And I think part of the reason maybe why you previously had those three pieces of software not talk is because the traditional manufacturing, or I should say, like product development lifecycle for these kind of products was like you would spend 10 years designing it, and then you'd lock the design and you before you even build any, you'd be like, all right, the design's done, right? We're never going to touch it ever again. And then you'd go make it, right? And and so you end up in this world where you didn't need those pieces of software to talk because the just assumption was they were separate independent entities, right? But I feel like now what you see a lot of more people doing is this like constant iterative approach, right? Design it, build it, test it. Oh, it failed. Go back to design it, rebuild it, test it, right? And when you end up in this loop of constantly iterating, now suddenly you want all of this software that previously maybe was a little bit more siloed to actually start talking to each other and sharing data.
We actually see that really commonly. It's like this interface between the R&D to the manufacturing side, and there's all this rework. So I think like the big metric we hear a lot from our customers is like, how do we reduce the rework when we hit the manufacturing phase?
Yeah,
sure.
And I think the other thing is like, there hasn't really been good test software, like, software to run tests, software to analyze data coming out of there. Like a lot of that stuff is generally proprietary to the instrumentation that you use and whatnot. So I think that whole side of now, like you have the systems to build, you have the systems to test and analyze data and kind of make decisions there. I think that's like a huge thing, to focus on as well.
Chris,
Yeah,
you mentioned a little earlier in the conversation. Sorry, Karthik. I'll come right back to you. Chris, you mentioned a little earlier in the conversation. You brought up the example of a 15% startup. I'm kind of curious, like, when do you think it makes sense practically for a startup to be thinking about this problem?
That's a great question. It's always before, right? Like the easy answer is, oh, you have a problem. And then you go, man, suddenly we need traceability, right? But ideally you don't want that problem. But it's also challenging because like, I think maybe to take a step back, like processes and systems evolve and ingrain themselves inside a business as that business grows, right? If that 15-person startup could remain a 15-person startup and also grow and to become a like multi-billion-dollar company, maybe they could get away with just everyone tribal knowledging their way through everything. But realistically, that 15-person startup in the next 2 years is going to become an 100-person or 200-person or 500-person startup, right? And it's that growth that suddenly drives the need to ingrain process and systems, right? And so really it's like, when does someone need to start thinking about this? It's when do you want to start growing, right? When do you want to start taking your business and moving away from this tiny startup into this bigger business? And that's when you want to be like, okay, how do I make sure that I embed into both the culture, but then also the systems people use, the things that I think are important?
I like that. That's a really good point, Chris, right? Like I feel like if you feel like you need it, you're 9 months behind is generally what we say, right? And I've also noticed that like the tipping point I like to look at it is when the design engineer and the responsible engineer and the build engineer or whatever the engineer you've got title is not intimately involved and hands-on part is probably the best indication of when you need it, or when you're heavily reliant on your supply chain. And the supply chain can heavily influence you is another one where you should really, really consider this. Like, do you need it at the start when you're, rapid change engineering on engineering? Probably not, right? But like that's usually the part where I see it, where we see it is when are you going to be able to sleep at night, right? If you know the part's still working without you being there. That's really the metric.
There's still value in the development part of like product's life cycle to have that. I mean, the reason why it's not is because, like I was saying before, the overhead and kind of capturing it. And that's where it's like, if you put a part on a test stand and it's streaming data, it's like as long as you as long as that's easy for you to kind of like access that data and use that data, it's like, it's imperative with production. It's kind of a nice to have in development, but maybe we move to a world where it's just so easy that that you just get it for free.
For funsies. Yeah.
I think that's actually an interesting point to cover, your own, which is like, it's like, how do you default that rather than making it like an additional step or process? And I think that's where like Manufacturo comes in a lot, which is like, how is it that you have the interfaces in the MES that are just capturing that data throughout the manufacturing and the build process?
And not feel like bureaucracy, right? Like not feeling like, oh, you're punishing me for doing this.
The mortgage app. Yeah, you don't want the mortgage application.
Yeah, exactly.
Let's talk a little bit about traceability in aerospace versus other industries like automotive. Where how does it differ? How does it compare? And do you think the space industry should be leading or learning in traceability here?
That's a good question. I think you tend to design a lot more custom parts in the aerospace realm, I think, and a lot of what you end up building is like unique, bespoke, one-off things. And so I think that ends up driving to needing what that drives two things. One, I think, is you become extremely supplier dependent, right? Because you end up having to outsource a lot of these things, these like special components that you couldn't just buy, right? And then the other is, I think you now really need to understand down to a fundamental level, what are the failure modes of these things you just designed, and what pieces of information do you maybe need to capture in order to do so? That maybe isn't as much so in a world where you're just purchasing a bunch of commercial off-the-shelf parts and slapping them together to build something. So like, there's just a fundamental design change, I think. Additionally as well, like you run into a problem of like quantity, if that makes sense, right? Like if you're only purchasing 5 of something ever, you really need to make sure those 5 things work, versus like if you have like hundreds of thousands of things moving through a factory an hour, like having one thing work and throwing it away and grabbing another is like not as big of a deal. So those are kind of the 2 largest changes I see.
Yeah, I'm pretty lucky in my previous life, like before SpaceX, we did a lot of industry, and automotive is just incredible. The amount of traceability they get, the synchronization they do is just incredible, right? And there's so many other industries, like we did a lot of work with tobacco companies, and the amount of traceability they get and the optimizations they get, food, beverage, med device, right? There's so many things aerospace does very well, and there's others where they can really learn from these other industries, and that's where I feel like you've got to start bringing those industries in, like Kanban, for example, super simple example, but like just like getting that line side, like Chris can tell you the ramp up that we had at SpaceX, and we were a small part of that, and Chris has honestly led the way on that, but it was completely different, and the mentality was the same, but the methods and how you did it and the mechanisms to do it was much different, and I think they can learn from each other, right? Like,
yeah. I think what you see really done really well in automotive and other, I'm kind of call that like medium volume manufacturing, is like traceability is designed in from the beginning, right? Like it is an automotive, there are engineers whose full-time jobs are to sit and watch a person work at a station and figure out how to shave seconds off that person's time. Because if you can save 1 second off every single station that works 60 seconds, you're going to drastically increase the output of an automotive line over the course of a year, right? So time matters to them, and they have optimized so well how to capture the information they need, to the point where maybe there's like a fixed scanner that just automatically scans something when a door is, grabbed off the line and installed onto the car, right? I think it is requirements that are agreed upon before the design of that area is even built, right? They know, hey, you're going to need to scan this thing, manufacturing engineer, make sure it's done. I feel like what you tend to see in aerospace land is that's like the last thing that's thought of, right? And so it's like, all right, well, we already built the station, we already have all the parts. Oh crap! Like maybe we need to scan it. Well, where's the barcode? Oh, it doesn't have a barcode. Well, it came in the bag. Where's the bag? Oh, the bag's in the trash. Crap, you know. And so you end up in this world where like people forget that they need to do this stuff because they're so focused on designing the part, they don't think about the manufacturing process as well. And granted, I get, okay, if you're only going to build a handful of something, maybe that's something you don't need as important. But the problem is you want to ramp and you want to scale and you want to grow. And so like really trying to challenge yourself to figure out like, what would I do if I needed to build, 1,000 of these a month or 10,000 of these a month, I think would allow you to start thinking about how to ingrain the traceability, just directly into the manufacturing process.
So
yeah, go ahead.
Go ahead, Yaron. Go ahead, Yaron.
Yeah, I was gonna say on the other, like some differences, generally in aerospace, there's a lot of scrutiny over stuff. When you start thinking about why traceability matters in the consumer world, it's like one little problem could propagate to a lot of people. So, you could have a charging unit that overheats and potentially causes a fire because of a bad part inside the unit, and you need to go through and recall and contain. Granted, those problems kind of exist in every industry. So in automotive, there was a pretty big recall about airbags years ago. Used to use that as an example when we were introducing more stringent containment processes at SpaceX. That airbag was like, unfortunately, there was a problem in building it, and it was like, shooting out shrapnel when it would release. And it's like, obviously you don't want that to happen in a consumer product. And so kind of those high volumes that Chris was talking about, you mix that with like any sort of build or assembly or supplier defect, that could have like a mass impact. And so, the same thing for rockets and planes. Like if something was not installed correctly, or, maybe there was some notice that was sent out about a certain part being bad and you couldn't contain it fast enough. That all kind of plays a role there. But volume also kind of changes what your, so to speak, blast radius is with regards to doing a recall.
So we have a lot of SpaceX heritage on the call. So why don't we let's talk a little bit more about real world moments where we've seen unlocks based on doing this well. So I mean, why don't we start there? Let's talk some examples. Like you can talk CRS-7, Chris. You can talk about Starlink. Like, would love to hear about what happens when you get traceability right.
Yeah, like
sure, I can talk.
Yeah, please,
Go ahead,
Chris, you're the veteran here, man.
Okay.
So
Well,
please.
I'm gonna talk about the Starlink one because I actually think this is a really interesting example that isn't as like doom and gloom quality based. But Starlink, every single dish has this ID inside of it. We take an electronic chip and we place it on the circuit board of the dish, and that chip has embedded in it a unique ID. And every single dish in the entire world has a unique ID, and we use that ID on the network in order to know like what dish is talking, is it allowed to talk, has that customer paid their service, et cetera, et cetera, et cetera. And we put this chip on the board super early on in the manufacturing process, and we were given this mandate by Elon that when a customer opened up their Starlink box, all they needed to do to get online was take it outside and plug it in, right? That was it. No setup, no app linking, no account flows, take it outside and plug it in. And so that customer requirement kind of funneled down into a requirement for me as the kind of the designer of the traceability of the system at the time was I needed to know to 100% accuracy every single dish that was sent to every single customer anywhere in the world, including through the manufacturing process, right? The circuit board is the very first thing we do. And that circuit board gets installed into a dish, and that dish gets installed into a box, and that box gets shipped to a customer. And if we got that wrong, we would think the customer had a different dish than they actually did, and it wouldn't work at their home. It would just be straight up dead on arrival. Like, what an awful experience, right? Like you'd plug this thing in and it just goes, I don't know where I am, what's going on? So that ended up really driving from day one, like, how do we do this, right? How do we make sure that we actually know to as high of a level of accuracy as possible as to like where everything went, right? What customer ended up getting what unit. And so that like kind of, from day one, we knew like this had to be just as important of a manufacturing process as like making sure you put bolts in and screwed them on correctly, right? It was just another step. No one's going to sit here and argue that we shouldn't put the screws where the screws go. So we had to make sure that no one's going to sit there and argue we shouldn't do the scan when the scan has to be done, right? And I think we were able to, like, when we knew we had this firm requirement of making sure that every customer could get online seamlessly, that drove us to just design from the beginning, how do we make sure that we capture the right information at the right steps in the process? And it obviously worked out well, right? People get online all the time and we know where everything's going, but it was an example, I think, of traceability being 100% needed in the process rather than maybe something you lean on in like a time of, you know, things not going well.
Yeah, I have another positive one, Chris. I love that story, right? Like we had one where we did a project, Yaron and I probably had nightmares about it, the whip trace project, right? It was 9 months.
Oh, yeah.
And the general thing was nothing. When a worker got it created, we created trace immediately, unless it was a true rework, you know, and then you had to force to install it straight away. But we did it up front. 9 months, it was incredibly complex, basically changed our whole manufacturing engine in the background. And it was for traceability. And we thought, okay, people are going to get angry, but the opposite was actually true. We went live. It was a pretty seamless go live. But more importantly, the week we went live, 20% increase in completed parts. 20%. For the size of SpaceX, 20%. And I thought it was we're just learning, right? That was a fluke. We just did a mass close. But no, it never went below that the week we went live. And I think it was because traceability is also that visibility, right? Knowing where your parts are, knowing who did what, knowing where it is, scan discipline, making sure you're scanning where it was. And that was a very, like, I would say that's probably the most meaningful project I was involved in at SpaceX. I don't know about you, Yaron, and you can share your thoughts on it, but traceability doesn't need to be this cost. It can be a benefit, yeah. And that was what was one of the cool projects.
So I had like the opportunity to kind of work two completely different, like, well, kind of different like perspectives at SpaceX. I started there in build reliability, and then I moved into software and joined the warp drive team with James afterwards. So when it came to containments and stuff, I was you know, one of the main people running the mass containment if things you know, went wrong. And I want to say, like, early on it was incredibly challenging and difficult. I think we mentioned CRS7 earlier. That was caused by a strut failure. So I spent months containing hardware for that failure, like personally containing stuff, like going to inventory, grabbing stuff. And, you know, I would say with regards to, you know, some functionality that we introduced to make things easier, and this was all possible because of the traceability stuff that James and Chris had been talking about. We built this application called Impact Analysis, where you were able to indicate any unique identifier, any part. You could search like whatever you know about the part, and it tells you exactly where they are. And we ended up getting that process of months and months to perform containment down to pretty much seconds, where you could go through and select the things that you want to contain, and it automatically put holds on them. And so, you know, that's kind of the thread that I was saying in the beginning, where the software needs to help you. You know, initially the software wasn't there when we had issues like CRS7, and it made this all so much more difficult. And underlying, you can't have these cool tools unless you're actually capturing the right data and having it like organized and, you know, digestible. And so once you capture that data, you could build cool tools like impact analysis, and you could really like streamline, you know, these types of activities like containment. But CRS7, yeah, that was pretty rough. I mean, you know, I think it was very much, in my opinion, a turning point for SpaceX in taking a lot of this stuff more seriously.
Wait, Yaron, do you want to explain what happened and then what we did after?
What's that?
I don't know if everyone's familiar with CRS7 and what happened.
Oh yeah, I briefly mentioned there was a basically there's these carbon fiber like pressurized vessels that contain helium in there, and they're held together to the rocket with struts. So, helium tanks are extremely buoyant, so you need struts to hold them in place so they don't like jostle loose um, and cause problems. So one of those struts broke. And there was a material issue. I mean, there's a ton of stuff online about it that folks could read about, like details. But basically everything was like it was more or less pinpointed to a specific part that we were using that needed to be swapped out with a better design. So yeah,
I think maybe
and
Yaron,
that
to add
part
on
was
to that.
everywhere within the facility.
Yeah,
So it was
that's the
used in a
key
lot of
part, right?
places.
Is the part particular that failed in the strut was a rod end, and
Yeah,
rod ends were used like all over the vehicle, like quite
literally
literally,
everywhere.
like probably on the order of 1,000 plus per build. And so, when we realized we had this issue, it was like, okay, now we need to go get rid of all these rod ends. Well, holy crap, we've got 5 vehicles work in progress, and there's 1,000 per. How do we find all these things, right? And that ended up being a huge challenge, especially because this part, for those who aren't familiar, it's common almost as like a bolt, right? Like you're just using
It's
them all the
fascinating.
time. There's just boxes of them on the floor. When a tech needs one, he reaches to the box, grabs it, throws it on the strut, and keeps going. So that ended up being, I think, part of the issue is it wasn't just it was the failure, but then it was also the response to the failure, which was, wow, crap, this part is not good. We need to get rid of it. Oh
It was
crap, we have no idea where it is.
there were even cases when we were doing containment that those were in other parts that were not struts, and it was like, you know,
Sure, right.
it was just kind of they were everywhere, and that's kind of the problem when you deal with high volume parts and or like a lot of parts, and when those have problems, it's like, your blast radius is pretty large. Instead of just containing a few assemblies, you're containing hundreds, if not thousands,
At multiple
which is
levels. Yeah.
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 One cool thing I found out was, and I don't know if this is completely true, so asterisks, is that they use the telemetry system and figured out when they lost signal to actually on the rocket to actually triangulate where the problem was. And I thought that was genius if that's true. I don't know, Karthik, you might know more than me, but
I wasn't there during that time. I think
no,
that was
no
before my
excuse,
time.
man. No excuse.
James, it was it
You
was
know everything about telemetry, man.
Yeah.
it was the accelerometers, James. So there were multiple accelerometers around the LOX tank, like some on the dome and some on the side skins. And so I think they were able to, based on like the pressure, the sound pressure wave traveling through the LOX, were able to triangulate where the actual defect happened. There was Hans like giving a really poor talk on this, and they actually were able to take those acceleration signals and turn them into noise through like a bunch of signal processing, and they could actually play back what the failure sounded like as the tank bounced around. It was pretty crazy.
I mean,
So rad.
I didn't. Yeah, I completely forgot about that. And I mean, that's kind of the thing about connected systems. It's like, in order to actually get a root cause and corrective action there, it's like you're dealing with more than build data. You're dealing more with, I installed this piece here and there. It's like you're dealing with the actual data that's streaming off devices, where it's like that's just like so far beyond like what some companies are even like thinking about now. And yeah, I mean, Karthik, like, yeah, I guess like curious, like from your end, like, you know where, like, with some companies that are earlier on, how they're even like thinking about like data capture and telemetry and
Yeah,
whatnot.
yeah, of course. I mean, I think you guys nailed it on like the actual like why is this important? One more point on like why is this important? I think the stat was like it's not just about losing that $100 million rocket. It's a $500 million process of root causing the issues, doing the containments, fixing things, and it's like and also the lost business, like the lost business while you're not able to launch. And especially in these like very mission critical industries, I remember like we've had launch failures where, or like they weren't even necessarily failures, but they were like launch anomalies, like something may have broken that like held back Dragon missions. When I was working on the Dragon program, where they said we have to go figure out what happened here on this Falcon rocket before. I think it was like there was a rocket, one Falcon that didn't land properly, and we had to disposition that for NASA before we could launch that Dragon mission because they want to make sure that everything's working properly. So it's like there's a lot more second order effects to it. Um, but going back to your question, Yaron, I think the concept that we talk about a lot is um, what you guys are talking about is more of this like broader idea of knowledge transfer. And the way I describe it is it's kind of like uh, energy transfer. Like if you think about when you're driving a car, um, of the gas that's in your engine, only like 6% of it goes towards kinetic energy, 94% of it's lost to heat. So it's kind of like the same concept with knowledge transfer, which is like when you change between what you're doing at R&D to manufacturing to operations, that's when you lose all this context. So by the time someone's operating in the field, they have no idea what this like weird behavior is. And it's like, how is it you can capture some of these insights during the earlier R&D stage and have that live with the hardware? And that helps with reliability, but I think it also unlocks really interesting like operational capabilities, like what Chris was talking about, where we can literally create this amazing user experience where you just like plug in the Starlink and it works. And that's because they were using the same system through they were like enriching the data through the manufacturing process. It even goes back to like when the customer purchased this, and it lives with that hardware throughout the entire life cycle. And what we also see with some of our other customers that have, I think aerospace is like going back to like what you're talking about other industries. I think like one of the bigger differences that we see outside of aerospace, I mean, like I think Falcon's unique, but like in the sense that like maintenance isn't as common in aerospace because once you launch the satellite, you're not repairing the satellite. It's like it's one and done. Whereas, I mean, there is still an aspect of like how do you build the next satellites better and more reliably, but like what we see across, especially like shipbuilding, and it's like a lot of these pieces of hardware, it's like some of the ships we're working on are like they're like 30 years old. Or for example, what is it, the B-2 bomber? I didn't realize it's like what 60, 70 years old, and they're trying to make that thing last for over 100 years. So I think it's like how is it that you can really reduce that knowledge transfer throughout the hardware lifecycle from R&D all the way through the sustainment. Um, so
Yeah, I want to kind of expand on that a little bit. So just on this kind of idea of data capture, it's really easy to capture a shit ton of data these days. How do you balance capturing enough data without creating like, data tombs?
when you say tomb, are you talking about like silos or just like
Yeah, just like
these
silos
like
or like
deep pits?
deep pits that like no one's really using or no one's like accessing nearly as much as you would think or you'd want to.
Yeah, so it's like
And
how do
I
you operationalize this data that you
yeah,
capture?
yeah.
Yeah, of course. I mean, this is actually where I think maybe Yaron should share a little bit what he's doing with Magenta, which I think is like a really interesting, like more advanced use case um, of what to do with all this data.
Yeah, I could talk through that a bit. Yeah, I think generally data comes in a lot of forms. Like you obviously have your test data, you have your build data, you have your organization data, and all of this is just context that engineers need to know exists. And so, you know, they're all kind of disconnected too in some regards. Even in systems that I've worked on where it was all within the same built within the same system by the same team, there's still silos that end up existing. So a big thing that me and the team are building with Magenta is a way to kind of stitch a lot of like the fragmented data together to help answer questions and solve problems and streamline work. So an example is, I started building this piece of hardware. Maybe there's some issues on the shop floor. Maybe as I started testing it, there were some problems with the data. I have some feedback from technicians. Maybe some industry standards changed. So this is all context that engineers need to have, and they need to go and dig into each of those data silos to understand what happened for that specific part. So what we're doing is building mechanisms like basically through AI agents that are able to help you go and sift through that data and understand what you need to do differently. So stuff that would normally take you weeks upon weeks of work to do, we're trying to get down to a much faster clip where it's more of a task than a project. So the next time you go and try to revise like your process plan, you're kind of armed with this data of, hey, I had 3 failures in this case. Like we had some data anomalies from the ATP that we ran, and you know, would you like me to suggest how to prevent those moving forward? So it's a pretty cool tool. Actually made the formal announcement of Magenta to the world yesterday. So there's a LinkedIn post that you could check out for more info. But I think the point is true. It's like people are constantly collecting lots and lots of data, and it's like, you know, what are you gonna use it for? And you need to make it accessible. And I think that's a key thing there.
And also one thing to add on that, I think it's like just I want to highlight one aspect, which is like I think it's important to capture the like operational context in line with the data. So what I mean by that is where it's like uh, what James and Yaron are doing on the manufacturing side. It's like when you have test data during the manufacturing process or like QA type of data, capture that in the MES. That's the operational context. Whereas when you have this like operational data, like the service, like for example, like service life, or just like performance data of like the engine out in the field, then you want to be able to capture that in a way that it actually matches like that genealogy tree that like Manufacturo has. And then this goes back towards my world, which is on like the flight software side, which is when you are actually like dispositioning, or let's say you see anomalies in the field, or even during like R&D and simulation, you want to capture that the operational context for like a simulation engineer or like a flight software engineer is hey, we ran these like tests and like it didn't behave properly here. What went wrong? You want to capture that data. That data shouldn't be living in like Jira tickets or Slack threads or Confluence or email. I think like it was or like email. I think the most common place this stuff lives is like PowerPoints that are screenshots that are then put into email threads, and then you forward email threads. Whereas all that type of like operational context, like, hey, this is an anomaly. This is what went wrong. You should capture that in line with that data, with like that telemetry data itself. Um, yeah. Sorry, and that just to add on that mode, what I meant by that is like when you capture the operational context and the raw data itself together, you don't really have like data silos in that same sense. Like they're not like data tombs, as you said, because it's all you're making all that data useful itself, so it never really goes to die.
Yep. Just in the interest of time, I just want to let the audience know that if you guys do have any questions, you can use the Q&A button at the very bottom to type in your questions and ask them. We have a few final questions to go through, but that are a little bit more on the practical advice side. But I'm curious for the group, for teams that feel like trapped by legacy infrastructure, and there's many out there, you know, that want to, but they want to improve traceability. Like, what advice would you give to those teams?
I can take a crack at that. Like, this is what a large part of what we do, right? I think a lot of people feel trapped because of their current systems. And it's not as bad as you think, actually. I think a lot of people feel like they're not ready. Well, there's nobody really is, right? Typically, a lot of the things happen because of something bad. Like, try to avoid that, right? So I would say, okay, if you need to, if your current system or infrastructure is not working, you got to get off that, right? So what do you need to do to get off that? Find a solution and platforms that can expand with you, that are ahead of you. One of the biggest factors is migration. Like, do you really need to migrate everything? You know, this data is often their handcuff, and is that data even good? So trim away as much as you can. Understand why you're trapped. Is it truly a system problem, or is it a cultural problem? Like, is it because you've just done it the same way? And if you do find all that, don't try to boil the ocean. Like, what are your biggest risks? Start there. And often I find starting when parts enter is usually the best place to start, and go from there. Can you try to map the data to a problem? And I think I see a lot of the fear is associated with seeing data as like this red tape, like we talked about. We joke about the mortgage application, but not as a problem-solving possibility. And if you do it right, and Yaron's mentioned this a few times, it should be little to no overhead. In some cases, it could be an advantage because you actually have that traceability of where a part is, what touched it, who did it, so people know where it is and can go get it, so you're not searching for it. And you should try to automate and make it conditional and feel part of the business flow as much as possible. Like, try to say no to that bloat, right? Like, that's my advice, but it's $1,000 million question there, Mo. You know, like, you got to start, right? Don't wait till something bad happens to be your trigger, right?
And we actually do have a question here related to this. How do you convince leadership to invest in traceability when it's when they see it as a cost center?
Well, traceability, it doesn't have to be a cost center, right? Like, people see it as like a non-value add activity, but you know, what's the cost of finding that problem? Also, like, how do you manage what you're not measuring? Like, that traceability is the backbone of that. That genealogy is the backbone of that. And how do you then utilize what you've done in that? Like Yaron mentioned, like, there's value in even the dev portion, right? How do you make sure that tribal knowledge is not lost? How do you make sure that that work is not lost? How do you know that you can upgrade and use that, and the pedigree of the part is really good? Like, I would like to reverse the question: is how can you not do this? Is kind of like, when is that? Are you going to wait for that critical and bad event to be your linchpin or to do this? Like, it's pretty dangerous. Like, do you want to gamble with that? It seems pretty scary. And I get it, right? It's expensive, it's risky, and there is downtime and there's cost to get started. But if the system is designed right, then it should be very little, if not no, overhead. I don't know if anyone else has any comments about that.
We did have another question. I see, Rowan, you just answered. Do you see AI agents and software eventually incorporate to the product lifecycle?
Yeah, and the answer that I put in there is, you know, and this is how I, you know, incorporated it with Magenta. But, you know, we have the ability to take in your organizational documents like AS 9100, you know, whatever best practices, formatting guidelines, you know, maybe the way that you kind of populate and fill out forms, and use that as guardrails for the generative piece of our platform. So it's totally possible. We're doing it, and you know, I think what makes it more powerful is it plugging into other systems.
So I don't want to open up Pandora's box with this one, but how do you handle traceability for software-defined hardware?
Can you explain that a little bit more, Mo? Like, are you talking about like traceability on like a SIM, or not sure I follow?
Yeah, I'm not sure. You would know better than I do, but okay, let's unless anyone has any thoughts, we can skip that one.
We try to treat software like a product. So should be version, it should be revisioned, you should install it, you should uninstall it. The more you can treat it like a part of the product, the better.
Version control is a key thing there. As long as there's version control. Yeah.
Is there a point where traceability becomes overkill?
Sure. Lots of cases, you know. Sorry, somebody else can go. I've kind of been a lot of talking.
Yeah, I mean, there's like the concept of like lot versus serial tracked parts. Like, you're not going to go and serialize a bolt. Like, I mean, you could, but like, there's no benefit to it. It's like generally how you deal with traceability with fasteners and stuff like that. It's just batches. Like, you made a bunch of things at the same time. They're in a bin. They scoop the parts from a bin, put it into bags, and slap a label on it. You know, you're not going to serialize each part because, you know, generally serialized parts you have to like part mark, and there's a lot of like overhead. associated with it. You don't do that on specific things. So
I think it has a lot to do with your risk posture, right? Like, how comfortable are you with the loss of something? And that posture is not the same for every company, and especially not the same for every like organization. So that's the most important part. If you find yourself doing more traceability than you really should based on your risk, you probably want to think about pulling back.
And then maybe just as we close here, if there was one sort of blind spot every team should investigate tomorrow, what would you consider that to be?
I think it's the recall of the information you capture. I think a lot of people forget about that. Everyone's like, oh, don't worry, we're storing it. We captured it. But then when it's a it's a huge fire and you now actually need to find the information and take action on it, that's when suddenly you realize you have all the holes in your system. It's almost kind of like backups, right? Like computer backups, sure, you're taking a backup, but have you ever tried to restore from it, And suddenly when your computer actually breaks and you try to restore, it doesn't work. It's the same thing. It's like almost like have a fake containment every once in a while. Make sure you actually know how to use the data you've captured to be able to help you navigate through the trace structure.
Yeah, and there's that piece, and there's also the interesting thing about what capabilities that are now possible with AI like enable that to be a lot easier as well. Because it's like instead of having like one set of eyes, you literally could establish thousands of set of eyes to automatically like cross-check and review. But yeah, it's a lot of people capture a lot of data that they don't use. So because it could be hard.
Yeah, I always say that just because you got data doesn't mean you have information.
Yeah.
Just because you have information, don't you have
Totally.
actions, right? Yeah. And I think just being able to make sure you can use it and get value out of it and create that culture of learning, I keep saying bureaucracy. I don't know of another word, but it shouldn't feel like punishment. It should feel like this is valuable, right? And yeah.
I think also like one thing just to add there is like I think when you're building a lot of new programs, especially when you're like doing R&D, it's almost as like this like breadth first search expansion where you're trying a lot of different things out. But then there's also this like paring back process. And I think it's like with Dragon, we had a lot of people as we built that program, but then it all became like buying down risk and cost. And I think doing that process is really important because that's actually what forces you to like look at some of these things. Like I think part of the reason why it becomes like such a big burden and process to do these things is because you have all these like different processes and steps and these like band-aids that have accumulated for decades on top of each other, and nobody actually like went in to say like, should we delete this part, this process, this step? And the people that are doing that step don't always have the autonomy to say that we should get rid of this in the process.
Amazing. Well, gentlemen, just in the interest of time, let's end right there. Karthik, Yaron, James, Chris, thank you guys so much for taking the time. I also love and appreciate panels where I don't have to talk a lot, and you guys are great. You guys did the moderation for me, so really appreciate you guys taking the time. This was great, and we will connect with the audience on ways to connect with you guys after the fact. So
awesome. Thanks, Mo.
Have a
Awesome.
great day.
Mo.
Okay, bye.
Thanks, gents.
See y'all later.